Good afternoon, everyone. Happy New Year. I think we're just about on the cusp of still being able to say that. Welcome to this Advanced Steel webinar where we're going to be looking at the difference between folded beams and folded plates. So I'm sure most of you have seen all of this by now, but for those of you that are new, my name's Rob Merriman. If you do have any questions, my contact information is at the bottom of this page, and we have done this as a handout. Or you can find me on Twitter or LinkedIn. So I've got 12 years of experience in the construction industry. It's the only industry I've ever worked in. I started off as a steelwork draftsman using advanced steel. I worked across 2 subcontract drawing offices for lots of different fabricators and suppliers. So it's given me the experience to do what I do now. So I am an application engineer here at Graitec UK. So I take that experience across the 2 drawing offices, and we now do demonstrations, training, technical support, implementation and customization for structural CAD packages, predominantly advanced steel, but with advanced steel being added to the AEC collection a couple of years ago, we now try and look at a little bit of everything. So some Revit, some Navisworks, some Fusion 360, and we obviously try and pass that on to you guys. So a little bit about Graitec. We are a 30-year-old company based out, headquartered in France, operating in 11 countries and over 48 offices. We are a healthy, growing and profitable company, and we are now becoming one of the largest Autodesk partners worldwide. We've got over 550 staff, 100 are based in our research and development center in Romania, developing tools like the Power Packs and programs like Advanced Design, and we are here to help all of you guys, our customers. So over our tech support, we have 98% excellent or good feedback, and that's over 50,000 support cases, and we deliver more than 3,500 courses globally. So why Graitec? We are one of the only companies that can take your project from start to finish. So we've broken a whole project down into our 4 sort of key pillars, which are create, simulate, fabricate, and manage. So create is using the Autodesk products and then enhancing them with the Graitec Power Packs. Simulate is taking that model and checking that it will work in the real world environment. So we've got products such as Advanced Design and Advanced Design Connection. Fabricate, obviously Advanced Steel sits in create and fabricate, but it's taking your BIM models through to the finished product and site delivery. And then all these pillars everywhere create data and drawings and documents. And usually you have to collaborate with an external common data environment. If you're working for 3 big projects, you could be working in 3 different common data environments. We have a product called Graitec OpenTree that will actually work with all 3 of those common data environments and do the hard work for you. This webinar is being recorded. It's one of the most common questions we get asked. So the session is being recorded. It will get uploaded to our content centers. So the content centers are industry workflows, best practices, tips and tricks, and we have a content center for AEC, MFG and structures. So it can take up to 2 weeks. It's usually done within 3 to 4 days, just depending on how busy our marketing department are. But it will go up there, and in the structures one, which is pretty much advanced steel, there are now over 50 webinars that you guys can watch on demand. Because this is an advanced steel webinar and we're based in the UK, we'll look at, just touch on the Advanced Steel Power Pack, make sure everyone is aware of what it is. So it is Graitec's add-on to Advanced Steel. So if you're, and this is a UK, if you're a UK supported and maintained customer, the Power Pack is free, it's part of your subscription. And we break it down into create macros. We have a structure designer. So anyone doing repeatable structures, you can actually create an entire structure with one dialog box. We have our own connection vault now. Anas, thank you for that. You haven't seen any of that, so it's just been me talking. It has just been me talking, so thank you for that, Anas. I will just carry on. I think most of you have seen this anyway. We have create element, so where we can create things like castellated cellular beams. We have the folded plate extender, which I'll look at the end of today's session. Helical or spiral polylines, glass panel creators. Got BIM import and export tools. So we can, if you need to explode to ASYS, DWG, STEP or IGES, we can now do that for models, parts or assemblies. And then with the Power Pack, when the Power Pack gets installed, it actually installs extra data into your advanced steel as well. So if you're working with cold rolled, we've added cold rolled suppliers such as Stedman's, Thomas Panels, Hadley's, Kingspan. We've added the FH Brundle weld mesh and perforated panels. We've added ISA screws. If anyone works with square edge bars, we've added those in, so you don't need to manually change things. So they're all included with the Power Pack. So if you don't have the Power Pack installed, please just reach out to me directly and we'll get it sorted. If it's not working properly, anything to do with the Power Pack, please let me know if you're not using it and you don't have it installed. So today's session, we are going to look at the differences between folded plates and folded beams. Then we'll look at folded plate creation and editing. We'll look at folded beam creation and editing. We'll look at the drawing output from the system, and that's probably going to be about it. So it's about 40 minutes or so. And then I will just at the end show the folded plate extender from the Power Pack. So what are the differences between folded plates and folded beams? Well, if we're going to break it right down to basics, one is a beam element and one is a plate element. So Advanced Steel treats them in different ways, and as we go through today's presentation, I will show you that. Folded beams, myself and Alec were discussing this the other day. We define it as an element that's folded in one plane. So we can make that angle cleat there, and where you would use it is things like custom gutter profiles, cladding profiles, little flashings and things like that, but it's only beams that can be folded in one plane. We can have a funny profile, but we can't add extra folds in there. Folded plates you can fold in multiple planes. So if we take this angle, I've created this angle out of a folded plate, but we can add these extra folds onto the top, which are obviously in a different plane. Now you can't do that with a folded beam. So those are the key differences. In terms of drawing output, the system sees them both as folded elements, but when it comes to connections and things, one is a beam, one is a plate, if we really break it down. So folded plates, just because I've done this presentation as a handout, I'm going to put some key points on here, and then I've got pre-recorded video which I'm going to go through and let run with me making some folded plates and going through everything. The one thing we get on technical support quite a lot is, why is my folded plate drawn from the underside? Or why isn't it drawn the way I want it to? So wherever your UCS is positioned, when you model the plate that drives the folded plate, that is what the system uses to run the drawing. And unfortunately, there is nothing that can be done to change that. So your UCS has to be set correctly when you manually draw out the plates to begin with. There's nothing that can be done within the system to change that apart from deleting the plate and starting again. So that, if you take anything away from today, this is the critical bit. Plates can be drawn in position and then folded, or you draw all your plates out flat and then you fold them up and you put the angles in. So I'm going to show you both of that. Now, if you guys have been using Advanced Steel for quite a few years, I think it was 2018 it changed. Previous to 2018, you would select the fold and just hit the delete button, and then that would delete the fold. It was actually 2019. From 2019 onwards, you have to select the fold and then right-click and choose Delete Folded Plate Relation. Again, that is just a system setting that Autodesk have changed, so there's not much we can do about that, I'm afraid. And within your Advanced Steel model space, you can check to see if the plate can be unfolded, and the system will actually physically fold it flat. Now, when it's checking the unfolding, which I'm going to talk about in a minute, it won't tell you whether it's going to work for your tooling, but it's more going to be looking for modeling issues. So we'll go into a little video on this. It's about 10 minutes, and then we'll look at folded beams. We're going to start the session with folded plates. Now, folded plate is just a normal plate that is folded with another plate, so you do need to have the plates modelled to begin with. The one thing that drives everything with folded plates, and the one thing to be critical of, is the orientation of your UCS when you draw the original plate. This has an effect on the fabrication output, and once it's been started, you cannot change it. There's no way to change it. So the way we describe it to people is the XY is your piece of paper, and you draw down the Z onto the X and the Y. So however you want your folded plate to show on your part drawing is driven by the X and the Y. So we'll just show you how to draw, create a folded plate. There's a couple of methods to begin with, so I'm just going to put a couple of plates in, and we'll just make it 500 by 500. Now there's two ways of doing a folded plate. Folded plate without position adjustment and folded plate with position adjustment. So we'll start with folded plate without position adjustment. So what the system is saying here is you model your plates where you want them, and then we'll put a fold in. Set my UCS back to world. So I click the create folded plate without position adjustment. The plate that you click first is the main part of your folded plate, and then the plate that you click on is folded into that plate, and the system will create the fold for you. Now the other way of doing it, so that's without position adjustment. That's the method I prefer. Put your plates where you want them and then put the fold in. The other method is to do it with position adjustment. Now in the command line it says please identify the plate to connect to near an edge. So if I choose that plate there and the top edge, I can then say I want the top edge of this plate to be folded into it, and it will put the fold in, and we can say it's 90 degrees, and that will put the two folds in. So that is the way of creating your folded plates. If you want to delete a fold, you have to select the fold, right click, and then choose delete folded plate relation, and that will get rid of the fold for you. And I will just copy this plate to here, and I'll fold these up again. So main plate first, then the plate we're folding into it. Again, main plate we're folding into it. Now we'll just make this length a little bit shorter. Once you have a folded plate, the one thing that you can do with a folded plate is you can adjust the length of the legs. So you see in here I've got a grip in here. I can make that one longer, I can make this one longer, or I can make the whole edge longer. The same on this side. But I can't adjust the length from this side to this side. So I can't click and stretch this and make it longer. To do that, I would need to delete the folds. Then make these longer. So we'll make them 300 longer. And then refold them. So that is one of the things that we can't do with a folded plate, but I can grab this edge and I can stretch it up. And go to a wireframe. I can then stretch it up 200 mil. Now, while we're in wireframe, we have 3 plates that make up this folded plate. To advanced steel now, this is one object. And you can see that with every plate we draw, we get a crosshair, which is the center of the plate. Now, with a folded plate, there is a main object of the folded plate, and that is shown by this symbol in here. So the main object is the plate we click on first. So if we look at this folded plate here, this is the main object. Now you can change that with a folded plate. On your ribbon, you've got set folded plate main object. So if I want to, I could change that to this plate. And you can see now that this small fold here is now the main object. Now, the main object will drive our fabrication output and things like that, so we'll come back and look at that in a minute. How do we unfold a plate? Or how do we check that it can be folded? So again, on our ribbon, there's this little command here that looks like a flat cardboard box. So it says check unfolding. So if I click this plate here, it says it can be, in a command line, selected folded plate can be correctly unfolded. So it's looking for modeling errors in the folding. It obviously can't check it against your tooling compared to someone else's tooling. So if your tooling will only fold to a certain degree, we can't program advanced steel to do that, but it will check that you haven't put too many folds in, or you're trying to fold 3 edges together when physically you can't do that. And then it says, do you want to display the unfolded representation? So if we say yes, you can see that we now have basically a block of what that folded plate looks like. Now it is just a block, so we can just get rid of it. The other way to see or to flatten out our folded plate is to double click on the plate to go into the advanced properties. And then if we go to display type, you will see that we have an unfolded option. And that will flatten the plate out for us. Now what it does is it flattens it out from the main object. So if we have a look at this plate and I say unfolded, you'll see it's flattened it out vertically. That's because this plate here is the main object. If I change the main object back to the horizontal piece and I go display type unfolded, you'll see it will now flatten out. We can model on here with things that are flattened out. So if I want to put some holes in this leg that is running vertically, I can choose the center point of the plate. I can put my holes in. And then if I fold it, the system will put those in vertically because the holes are associated to that plate. So the system does know what it's doing in there. Now, just going to put a couple of plates in as an example. We're going to make them 300 now. We're going to make them 200 by 100. Have I got that the right way around? No, I don't. Make it 250. And then I'm going to copy that up to 90 mil. And then I'm going to move it back, let's say 100. And I'm going to put a plate in between these 2 plates. So I'm going to use the create plate at 3 points. So this defines the X direction and the length of the plate in the X direction, and then the length and the position of the plate in the Y direction. And then I'm going to fold these together. Now you can put contours and features and things like that into a folded plate and a plate. So we have these contours in here. We also have these orange contours. Now these contours work on plates. These green features work on beams, plates, gratings. They work on most advanced steel objects. So these ones in here, what is the difference between these ones here and these ones here for folded plates. Well, the green ones are based on the UCS, the orange ones aren't. So if I want to put a rectangular contour in the top surface here, I can choose a center point of the top plate and it will put that in automatically. I can also choose the sloping plate. Although all three are highlighted, if I click on the sloping plate, it will put it in the face of that sloping plate. If I choose the center of that plate, it will then put it in there for me. But these orange features, the ones that work on just plates, will only put it in one face. Now, if I want a rectangular contour that passes through the whole plate, I could use this command in here, rectangular contour UCS, but because it says UCS in the command, it's based on the UCS. So I need to change my UCS to put it onto the object. So again, if I do UCS at object and click the sloping plate, I get these little markers in here, which defines the CS. So you can see in here, the long line is the Z-axis, the second longest line is the X-axis, and the third is the Y-axis. So I'm going to click this one here, and that will set my X and my Y at the slope. So again, when I'm putting my contour in, the X and the Y is my piece of paper, and I draw down the Z onto the X and the Y. Now if I do rectangular contour center UCS, when I click on a folded plate, it will give me an option. Should this feature cut just a selected fold, or should it go through the entire folded plate? So I'm going to say, please go through the entire folded plate. I'm going to use a center point again. And you'll see this time that it's done what I've asked it to do. It's gone through the entire folded plate. So you can see that contour's going through there. Now if we flatten this out, we go display type unfolded, we couldn't get this plasma cut on most traditional machines. Someone did say the other day that they have now got like a 5-axis plasma cutter. So they could cut that at a particular angle, but most traditional machines, or let's say it was a water jet, that needs to be square cut. So at the moment, that plate there, we would need to take it to a machine shop and get it milled, which obviously costs more money. Now, what we can do with our contour that is very, very clever is if you go to the contour tab, you'll see you've got this straight cut option. And if I tick that, what that will do is that takes the extents of the cut, the one that is at the angle, and says, right, square that off. So if we do a straight cut now, it will still work to the extents of our cut, but it's made everything square. So there's just a couple of little tips and tricks there with folded plates. Now what we're going to look at is the drawing output of folded plates. So I'm going to set my UCS back to world. Remember what we talked about before, the UCS when you create your plate is critical. So I'm going to show you the two methods in here. So I'm going to draw a polygon plate. So my X and my Y is my paper. I'm drawing down the Z axis onto the X and the Y, onto that piece of paper. So just going to put a plate in there, and we're going to put a couple of folds in here. Not particularly fussed on the length of those folds. We'll just put them in as an example for now. We'll just manipulate that UCS. Okay, so I've got those plates in there. Now I'm not going to fold it up yet because I'm going to use those two plates on this one. But what I'm going to do on this in here is I'm going to rotate my UCS. So effectively we are now drawing from the bottom up, not top down, because I just want to show you what's going to happen in the drawing output when we get to the drawing output. Because this is something that cannot be changed. There's no way to change this behavior apart from redrawing the plate. So we'll just copy these, because to us in the model they look identical, but to the system they are different. And we'll fold those. So this is my main plate. I'm attaching this, I'm folding this. We're doing the same in here. Oh, got my folds in there. So we're just going to give these a model roll of folded plate, and I'll just number these two. Okay, I'm just gonna make one slightly different. So that we get two different part numbers. And then we want to run a drawing. So I'm going to use my processes, and I'm going to run part drawings for these. We just let the system choose the size that we need. And we'll just, so this one here, the one that was drawn correctly, is FPL1, and the one that was drawn the other way around is FPL2. So we'll open our document manager, which has popped up on my other screen, and I'll just open up the drawing so we can actually see what the system is doing. Now, out of the box, what the system will do is the system will give you your developed flat pattern, and it will give you one view for the folding. Drawing styles can be customized to show both. So FPL1, you can see that on this long leg in here, we have a fold up, which matches what we've drawn here. So on the long leg, the fold is up, and then on this shorter leg, the fold is down. So that's FPL1. So that is doing what we want it to do. FPL2, however, on the long leg, you'll see that the fold is down. Now that's because the system is viewing this from the underside looking up, not from the top looking down. There is nothing we can do about that because the system uses the UCS of the main plate when you draw it. There's no way we can change that. So it is critical you set these up correctly before you start modeling. And you can see that on the shorter edge it's going up. So there's nothing, I've got no tips or tricks for you here. There's nothing we can do about that. That is hard coded that way. So it is critical your UCS is orientated correctly before you start modeling your folded plates. Now, there is one management setting that we can look at for folded plates. You'll see that the system hasn't orientated this exactly as we've drawn it, because I had this edge here following the x-axis, this edge here following the y-axis. There is a long document about how the system draws the plates and how it orientates them and what it wants to do with them. Basically what it's looking for is it's looking for a right angle, and it will put the longest edge horizontally on the page. There's a lot more to it than that, but that is the sort of basic breakdown of it. Now, there is a management default. Just get my management tools open and on the right screen. So if we use the filter in here and we type CS for coordinate system, there is one that says detail the plates using the CS where the plates were created. Now if I change that setting, load it into Advanced Steel, and then just as a belt and braces double check, update the defaults, and I go and we update this drawing, what that default is telling the system to use is wherever the XY was when you drew this plate, use that when you create the drawings. So if I change this now, you'll see that that's rotated to match how we modeled it in the model. It won't change this leg here on the long leg, will still say down because it's using the Z axis, but that is where the XY was when we created that initial plate. So there's a couple of tips and tricks in there on what we can do with folded plate, but typically we would use folded plates in here, for example, where we've got a fold on this edge and a fold on this edge, because when we get to folded beams, you'll see that we can't actually do that with folded beams. Okay, so that's the basics of folded plates and a few tips and tricks in there. So David, I've seen your question. So David has asked if we've got a folded plate like this and let's just wait for my machine to catch up with me. And the material is others and durbar. How do we show where the pattern should be on this fab drawing? Because obviously you don't want to fold this the wrong way with the pattern on the underside because it's useless. The way I used to do it because we used to detail a lot of these, is make sure your UCS is correct. So you can, like we showed earlier, you can use this question mark on the UCS tab to check your UCS. So you see in here, let me go to a wireframe so we can all see it. I've got my UCS symbol there. The long axis is the Z axis. The second longest is, so the longest is the Z, the second longest is the X, and then the shortest is the Y. So we can see that we're drawing that top down. So that would be the first thing I would do, David, is always make sure that you're creating your plates top down. The way we used to do it is we used to put a manual label in here and said panel drawn from top durbar pattern to top face, and then maybe an extra label in here again saying panel folded from top durbar panel to this face, if we did put a label in. Now I will need to test this, so I might do it as a blog over the next month or so, but we could look to put, so I would do something like that and say durbar pattern to top face. I'm just trying to think. We could maybe create a new hole type or a center mark that if it had a particular diameter, maybe like 0.1, we could get that to go on to the drawing and then get the drawing style to label that so that it would show on this view and this view, but me and Alec would have to have a play about with that. So David, without really doing it manually, there's nothing out of the box you can do, I'm afraid. But leave it with us and we'll do a little bit of playing about. So that's folded plates. If anyone does have any questions on folded plates, type them in and we can always get to them at the end. So now we're going to look at folded beams. So with folded beams, you can create any profile. My personal advice would be to use your 2D AutoCAD setting out. So draw out the profile you want and then create the folded beam on top of that. When you're creating it, you do need to define the system line position. That's one input, and then you do the start and the end points for the actual length of your beam. And then your thickness and your radius can be controlled in the dialog box. One thing that I have only learned in the last 12 months or so is that you can actually edit the profile of a folded beam. I was always under the impression that once it had been created, that was it and you'd have to remodel it. If you change a display type to exact possible to modify section, it will allow you to actually edit that. So it's quite a useful little function. And because this is a beam element, the connections will work on it as they would do on an I-beam. So if you've got a funny folded profile that you need to put a small base plate or cap plate on, you can do that with the connections from the connection vault. To look at folded beams. So I'm just going to move my UCS over here. Now, from my experience, I would always draw out the profile as your folded beam with AutoCAD lines or a polyline. So we'll just make a little shape in here. The beauty of folded beams is we can make whatever we want. So like we said, a bit flashing, that sort of thing. So there's my shape. And then we're going to use the folded beam command. Now, if this was a polyline, I could click the polyline, but I'm literally just going to draw it out. If I turn my snaps on, we're going to draw out that shape. I've missed that point, so we'll just start it again. So we draw out our profile. Then, if you look in the command line, it's saying, please locate central point for the system axis. So this beam doesn't exist in the system. What this wants to know is, where are we positioning the system line? So I'll position the system line here. That's all we need to do. Now it says, where is the start point of the system line? So now we're into drawing our beam. So we want the beam to start here, and we're going to make it 500 long. And then the system will create that beam that didn't exist, that's 500 mil long. And we can make it 2 mil thick. We can then control whether the beam is created, obviously, outside, inside the line, or half on, half off the line. So you can control that like you can any plate. And then we can set the radiuses if we need any radiuses. Now, if you do have a polyline, let's make this 50, 20, 30, 50, and then we'll close it off, because we can make folded beams that are closed shapes. So if I click folded beam, I can now, in my command line, click on the word polyline, and then I can click that polyline. And then again, it's please locate the central point for the system axis. So I'll put the system line here. Where's the start of the beam? Where's the end of the beam? So we'll make this one 1 meter long. We want my beam inside. We're going to make this 2.2 thick. We're just going to put some radiuses. In fact, we won't bother with radiuses on this one. So you see in here, this is the key difference. Advanced Steel sees this as a beam element. There's no defining the main fold or anything. The system takes care of all of that. If we go back to the features, try and replicate what we did with the folded plate over here with the different contours. What you have to remember is, to Advanced Steel, this is now a beam. So these features here that work on plates won't work on the beam. These features will. But I have to have my UCS set correctly. That will always help. We'll just put our UCS there. I can put a little corner cut on there. We can do that. That's not a problem. We can put a rectangular contour in. Do mid between 2 points. Find the midpoint in here. That'll put my rectangular contour in. These blue features in here are beam commands. So because this is a beam, we can apply these features. So we can apply notches, we can apply shortens and things like that. And one thing to take into account here, just remember, this is, although it's a folded beam, this is a beam element. So things from our connection vault, like our base plate macro, will work on a beam element. They wouldn't work on the folded plates because they need a beam element as the input, but it will work on this folded beam. Now obviously it's put in a massive plate in there. We probably just want a small 8mm LT anchor just to show that it can be done. Bit too close there. You can see, although that is a folded beam that I've created as a one-off, I can apply connections to it. Now, one of the things I always personally thought the difference between folded beams and folded plates is that folded plates, we can adjust the length of this fold and the length of this fold, but we can't adjust a plate. With folded beams, I always believed that the only thing you could change is the length. You couldn't actually change the profile. So if you'd made a mistake or someone changed something, you would actually, I initially thought you would have to come back and then change the profile. But what I have learned over the last few years is you can change the profile of a folded beam, so you don't have to redraw it. If we go to the display type tab, you'll see that we have the standard, the features, the exact, the symbolic, as we do with everything else. For folded beams, we now have a new option called exact, possible to modify the section. So if we tick that and we click the section, you'll now see, maybe if I go to a wireframe, you'll see it a little bit clearer. You'll now see that we get these little grips in here, and we get these little grips everywhere. So if we want to make this move 15mm this way, and this move 80mm this way, and then this profile here come out 50mm this way, but we want to also move it back to change the angle 30mm, you can see that by changing that display type to exact, possible to modify the profile, my folded beam has completely changed. Now, because where we put the system line, we can't change the position of that system line, but we can manipulate the whole folded beam. So say you were doing a project where you had a couple of different flashings with a couple of different sizes, you could create the first one and then we could look to copy it for the second one and then stretch that around to achieve what we want to achieve without having to redraw a profile. So that is one very, very useful little part of the folded beams. Now, if we run a drawing for these, I suppose we need to number them first, and we should give them a model roll. The model roll, we'll look at the drawing output shortly. The model roll won't actually have an effect on the output of the drawing. The system knows it's a folded beam, therefore it will run the developed drawing, the same for a folded plate. So we'll just number these. And we'll run a part drawing. Now, if you get this little pop-up, this is just a little tip generally. Whenever I click on an advanced steel object, you'll see that we get the little UCS icon here. If you right-click too close to that UCS, it will give you the right-click menu for the UCS of that object. What we need to do is right-click a little bit further away, and then we get our normal right-click menu. And I don't have to go into the document manager. If I have a drawing, I can right-click on the part and then I've got Show Parts Detail, and that will open up the drawing for me automatically. So, same as the folded plate drawings, it gives me the developed flat pattern with the folding angles on there, and then it will give me the overalls. Now, because it knows where the sharp point is, it gives us the dimensions to those sharp points on the outside. So you might have to do a little bit of work to put your own dimensions in there if you need, but it will give you that information. Now for the closed profile, because to the system it's a folded beam, that's been folded and then seam welded. So the system will actually flatten that out for you and then give you the folding information here. So it has to flatten it out because we're not extruding it. It's not like an I-beam. If we were going to do it and you were actually extruding the section, then I would look to do it as a user section, not a folded beam, because they do behave in different ways. So that's the basics and some tips and tricks there for folded beams. Personally, the part where you can edit the profile of the folded beam, like I said, I didn't realize that till 12-ish months ago. So it's quite useful if you've got a few different profiles to do. You only need to model one and then you can edit from there. Now we're just going to spend about 5 or 6 minutes on the different drawing output. So folded plates and folded beams will give you the same drawing output. The system sees them as folded items that need to be flattened out. So on a single part detail, the system will give you a flat pattern and the folding information. Assembly drawings will behave as normal assembly drawings. So out of the box, you won't get a flat pattern if you run an assembly drawing for a standalone part. So a standalone part is a loose item. There is a management setting that tells the system whether it can run a single part drawing, an assembly drawing, or both. Probably something that you guys have changed over time within your management settings. Because I'm running an out of the box system, I'll show you what you get out of the box. So the last bit we're going to look at for today's webinar is drawing behavior for folded plates and folded beams. So we have two different scenarios in this project, scenario A and scenario B. So we'll start with scenario A. What we have is we have a folded beam with a welded cap plate. So if I use the clear marking and show me what's attached in the workshop, that's all one welded assembly. This item here, again, we have a folded plate with a closure piece, and that's all one welded assembly. So what we want is for these items, we want our part drawings. So we'll just run the piece part drawings. That's to give us obviously the piece parts for the end plates, the folded plates, the folded beam, and the cap plate. And then we want an assembly drawing for them, because the guys in the workshop need to know where to weld everything together. So this is scenario A. We've got a folded beam or plate with something welded to it. So if I look in the document manager, we have our piece part details. So our end plate, our folded plate drawing, and then we have our folded beam drawing, and then we have our assembly details. So that just tells us where everything is located and welded, but the piece part drawings here will give you the unfolded profile of the folded beam and the unfolded profile of the folded plate. So that's scenario A. Scenario B, we got all these items over here that are what we call standalone parts. So standalone part is an object in advanced steel that has nothing welded to it. And we can check that by going to the output tab and there is a little button that says mark loose part, so a standalone part or a loose part. And if I do that, you'll see that it's found 6 items, and these are the items in here. Now, Advanced Steel, you as the user can control what type of drawing you get for a standalone piece. And that is controlled by the management tools. I just want to show you what's going to happen for folded items, because we will get different drawing outputs. So if we go to defaults, drawing general, and then click on general, we have these 2 defaults here: behavior for standalone parts on shop drawings for beams, and behavior for standalone parts on shop drawings for plates. So because we've got a folded beam and a folded plate, we've got 1 default for each. So you see here, I'm using an out-of-the-box Advanced Steel. It says create both assembly and single part details. And if we click the drop down, we've got 3 options: create both single and assembly part details, create assembly detail only, and create single part detail only. So you know, we've got quite a few people on this webinar today. You'll all want something slightly different. Some people want a part drawing and an assembly drawing, but then to me you've got 2 drawings which are telling you to make the same things. The workshop might get confused and make double what you need. You could just have a part drawing, or you can have an assembly drawing. I think when me and Alec discussed this, we even have different ways of doing it. I've always done anything that is a standalone item or a loose piece, I've done it as only run an assembly drawing, because I want that to go into an assembly drawing that gives you the coating, and it tells a workshop that this is a finished item. Even though there's nothing welded to it, it is a finished item. So you cut it, you fold it, you crop it, you punch holes in it, and then it needs to go for finishing. Alec prefers to do it as a single part, because he says, well, it's a standalone item, it is a single part, so he puts it on a single part drawing. So I'm just going to leave my management settings on to run both, and I'll just show you the different outputs we get out of the box for folded items on single part drawings and assembly drawings. So we'll start with single part drawings. So I'll come to my parts process, just draw a window around these, and I'll tell it to do the selected parts. I'll let it choose the paper sizes and the sheet sizes. And when it's finished running, we'll go and have a look at what the system is doing, because we do get asked this on technical support. So you can see we've got S for single part, and then that is giving us our developed view here, and then the folding information on the other side of the drawing. So that is the single part, the piece part for it. So you get your flat pattern and you get your folded information. Now if we run an assembly drawing, so if we go to the Assemblies tab and I'll run Assemblies A3 single bomb, we will get a different output. And this is just the way the system, Advanced Steel, the GBR, the UK build, is set up out of the box. It can be changed, it can be customized, but we're just going to show you what the system does. So if we look, we can now see we've got the assemblies. If I click on the assembly drawing that I've clicked on, the one we did earlier, you'll see that for this folded profile, it just gives us a front view, a top view, and a bottom view. It doesn't give us the flat pattern and the folding information, so it out of the box. So if you just run assembly drawings for standalone parts, for your folded plates and your folded beams, out of the box, this is what you would get. So it's all controlled by that management default there: behavior for standalone parts on shop drawings for beams, or behavior for standalone parts for shop drawings for plates. So I'll set these to both do a single part only, and I'll just show you what the system will do if you set it to one or the other. Because I obviously now have an assembly and a single part drawing. So we'll just delete those drawings via the document manager. We'll just reload my settings. Because I've set it to shop drawings, if I select these standalone parts and run a shop drawing, a single part drawing, sorry, that will happily go away and run those drawings. And we can see that we have S for single parts. These are our single part drawings. Now, a couple of minutes ago, the system let me run an assembly drawing, but because I've changed the management setting, when I try and run those drawings, I now get a warning saying FPL1, which is a standalone part, so a loose part, this can only be detailed as a single part drawing. So as soon as you change that management setting in there, and I'll change it back just so I don't forget, the system obviously reads those settings and says, well, you've told me I'm not allowed to run an assembly drawing. So for standalone items out of the box, you might get different results for single part drawings and assembly drawings. So we just had a question in from Dave. Dave's asked, single parts only as an assembly drawing, does that affect the NC setting? No, Dave, that management default is just for drawing output. So your NC settings won't be affected by that. The system will just give you, if you're running a DXF file, it will just give you the flat pattern. We are nearly out of time. I just want to quickly show you, we talked about the power pack earlier. So there is a power pack's installed up there. In the power pack connection vault, and I am going to do a webinar, we're going to do a few more webinars this year on the power pack. There is a folded plate extender. Maybe I went straight past it. Ah, sorry, it's not in the connection vault. It's there on the ribbon. It's under the create elements. So we've got a little button there, folded plate. So it adds a new fold to an existing plate, and you don't have to create the plate. So you identify the beam at a reference end, you select the edge where it's to be created, and the system will automatically put a fold in there. So you can control from the middle, the outer, the length, the width. So we can say it's minus 45 degrees and it will go back the other way, and the justification and the radius in there. So just a tool from the power pack, you can add these folds in automatically without having to model the plates. And that takes us to the end of today's webinar. So I know you've been asking questions throughout, but does anyone have any other questions at the moment? You do have my contact information and obviously the support system if you've got a support entitlement with us. I'll just leave it running for a couple of minutes if anyone does have any questions. But I can't see any coming through at the moment. So thank you very much for joining today. Like I said, this will be recorded. It will get uploaded to our content portal. So I would say hopefully by Wednesday next week it will be up there. If not, it can take up to a couple of weeks. So if you did miss anything, you want to go back over anything, you can check it in our content portal.